Audio. And the lovely voice of the computer tells me that recording is on. So probably not the best time to announce any secrets you don't want the NSA to hear about. So again, for the purpose of the recording, my name is Alan Smith. I am Fabiola's partner in crime for the LabVIEW Architects Forum, which is Austin's user-driven LabVIEW user group. Having just said that, tonight's meeting is brought to you almost entirely by National Instruments. We do have SixClear is helping us out with our AV again, which is awesome because I'm all thumbs when it comes to that sort of thing. But other than that, the food tonight was by NI. All three of our speakers are National Instruments employees, as it turns out. I guess that has to happen from time to time. Anyway, so tonight we're going to have a recap. I will be talking about the America's CLA Summit this year. Darren Nattinger is going to talk about his experiences in Europe. He got to be one of the cool kids this year, and I didn't. I'm so envious. And that'll take our first half of the session. And for the second half, we're going to have Stephen Mercer's excellent session from last year's CLA Summit in Europe. It's a presentation that I'm very fond of, and I don't think it gets enough attention, which is why we're going to have it tonight. Any questions before we get started? Any procedural items? Anything I need to take into consideration? Or I'll just start talking. You know what? I'm not sure sign-up sheet made it downstairs. Can somebody, after I give my presentation, I'll duck out and get some paper and see if we can get a sign-up sheet going. Okay, so thanks, Scott. So without further ado, how many in this room attended the CLA Summit here? Okay, good. This will not be a wasted presentation. I was so concerned that everybody here would have gone. The CLA Summit, Certified LabVIEW Architects Summit, annual event. It has two parts to it. There's the Americas portion, which is surprisingly mostly attended by people in the Western Hemisphere. And then there's the European Summit, which is mostly serves the European market. There's some crossover. If it's a really good year, you get to go to both of them. And this is it. This is the peer group for LabVIEW architects. For many of us, this is a more useful learning experience than NIWeek. So, yeah, it's kind of a big deal for us. So I'm here to talk tonight and just give a brief recap of what we covered here in the Americas. Try to give you a taste for why it's such a cool event, what kinds of things we cover. Hopefully, it will encourage many of you to pursue your architect certification. This is a free event. You're responsible for getting yourself to Austin or wherever it's hosted in Europe and the event itself. And it's awesome. These are also community-driven events. There's usually some NI content, but it is mostly presentations by and for the architects community. So, excuse me, I need a little bit of water. Okay, so here in the Americas Summit was March 3rd through 5th, if I recall correctly. We had a few people show up. All photos in this presentation of the summit are Brian Powell's photographs. He went around and did all the picture taking. So this was the opening session. A few people attended, about 120. Which I'm not sure where that plays out in terms of record, but it was a lot of folks. We had so many attendees and we had so many tracks. We had 28 sessions total, which is the most we've ever had. And there were so many of them that we actually had tracks this year. The format in the past has been a single theme and basically we're all gathered together, which is awesome and a very intimate gathering, and we all get to share essentially the same information. But this year we just had too many sessions, so we split up into 3 tracks. There was the usual software engineering track that most of us have interested in on security and issues related to security, because that's on everybody's minds these days. And test stand actually made its first appearance at the CLA Summit. We had 3 or 4 test stand sessions. I didn't attend those, so I'm not going to talk about them because that would be sort of false advertising. But test stand does play a part in the role of most architects at some point. A lot of architects have to deal with test stand, and so it was actually good to see that we had sessions on it. The other thing that we had was we had sort of a mini summit for the embedded developers. We had the CLD exam, the initial exam was given, and we had several sessions. That was mostly by NI systems engineers on issues related to embedded systems. That was most of the third day. As usual, the CLA Recert exam was available for anybody who wanted to take it, and the initial multiple choice portion of the CLED was available as well. There was also a prep session. That was pretty cool. I spent most of my first day in the security track. That's where my presentation was, so I missed a lot of good content. It was inevitable. There were multiple tracks. You were going to miss good content. Security track started off with Security 101, which you don't know can hurt you. That was a little horror story told to us by Rob Mixer, who is the engineer in NI who oversees the efforts to make our products more secure. And that was a discussion of what he calls the attack surface. Just all the different ways that malicious people can get into your system. Well, it's not all, but a representative sample of ways that the bad guys can get to your system. He also talked a lot about who those bad guys are. Anything from your random disgruntled employee to, a government, and what the resources they can bring to bear and what their interests are. And all of this was by way of getting us thinking about really the kinds of problems that we might have to face. If you know what the attackers are interested in, you know what they're going to do. Gives you insight into where you might be vulnerable. That continued with some discussion of some of the things that you can do to make your applications a little bit more secure. One of the big take-homes from this, we're talking about sort of where we have some deficiencies in our products. It's important to remember that the entire industry, the entire test and measurement industry and control industry is playing a monumental game of catch-up since Stuxnet. So we're doing our best to get out in front and inform the community and involve the community. It's a big problem. It's not something that NI is simply going to be able to hand you a solution, but we've come to realize we can help and identify places where we are weak and where we need the community's help to be stronger, make our own products stronger. And it really is an iterative, and it's an ongoing, constant effort. That was the take-home, really the take-home for this first couple of sessions. We did get technical, a bit more technical. This was my presentation where I demonstrated a technique that we've talked about within NI for setting up secure communication between parallel loops running on a distributed system. So very typical, I've got some host UI and I got a bunch of processes on a remote target and I want to secure that connection. And that used SSL and web services and encryption. And it being me and it being most of what I talk about, it involved actors and actor framework. But the techniques are generally valid. You don't have to be working with AF. A good chunk of this material, you heard it here first, is actually going to be available during Alliance Day. If those of you who work for or are Alliance partners. And then we'll be able to make this content available again down the road. Mike Bailey, our guy in England, came over. He finished up the track talking about building AES encryption on an embedded system, which both from the security standpoint and also from the perspective of just building really efficient high-speed algorithms on an FPGA and kind of the pain points that he had to hit to go through that. So it was pretty cool. And that was the security track, and that was basically day one. Meanwhile, going on in the other room was software engineering. More sessions than I can go into here, so I'll just pick out some of my favorites. We had a session. What is Derek's last name? works for MGI, bright guy, has developed a debugging tool for actor framework that will let you, I'll actually talk about that. I actually have a slide on that. It's pretty cool because if you plug his monitored actor into your hierarchy, your class hierarchy, you get a number of useful tools, such as getting this tree view of the actors that you're actually running, so you can build up a system diagram. Also, with his tools, you can open up the front panel block diagram of any actor that you're running. That's a constant pain point because they're almost always they're reentry VIs, and you don't have direct access to them. You can stop them if they're running emergency stops or regular stops, ping them to find out if they're responsive. Pretty useful tool, and available on the forums. And I should have brought you a link. I can find a link if people are interested. So that was one session that I thought was particularly valuable. Dave Snyder gave us an improved version of his fundamentals of actor-oriented programming. Chance to see this session or something similar to it. I highly recommend it. It is very valuable for anybody who's working with multiple parallel processes that have to talk to each other. Basically, the actor framework space, but the principles that he talks about apply to multiple queue message handlers talking to each other. Basically, anything an advanced LabVIEW user who's working with concurrent systems is doing already could benefit from this. I like this presentation so much that with Dave's permission, I have lifted it in large measure into the actor framework course that I'm in the process of writing. Because it's really good at setting the stage and the theory and outlining some of the basic principles that you need to be successful. Darren and Nattinger had his Hidden Gems in VI Live presentation, which Darren's forgotten more about what's in LabVIEW than I'll. That was a really good presentation. There's a lot of useful stuff in there. And that's also, you're making that available generally, aren't you? Okay, yeah, that's a really good presentation that you can hunt down. There's so many things that we have to do when we're dealing, especially for scripting or any other host of operations, that we have to do internally within VI Live, and why reinvent the wheel if Darren's already written it. So, good presentation. I don't know if Fab's online, but I'll give a shout out to Fabiola. Her session on unit testing was informative. It was kind of a goad for me to go off and start working with Brandon. We're actually going to be looking at trying to make the barrier to entry for automated testing easier. And that we were inspired to do that to a large extent by Fabiola's presentation. And this is probably my favorite of the whole NIWeek, which is why I'm going to give you about 3 slides on it. Dimitri's second. How do I pronounce his last name? This is Dimitri, big white bearded Russian guy. He gave a presentation on dependency inversion. Oh, hey, we got sign-up sheet stuff making the rounds. He drew his talk primarily from a book which I'll mention shortly. But that book is a discussion of Agile. It kind of goes to the heart of what I do in my day-to-day job, which is Agile software development practices, which is a type of project management, very effective project management, and using object-oriented in that environment. And the book outlines several principles, of which 5 are of interest. Single responsibility principle, which is the idea that a class should do one thing, so that if you're not trying to change, if that one thing has to change, as a class is responsible for it, but that class is only responsible for that thing. So the number of vectors of change in a class is kept to a minimum. Open-close principle, which says that you can extend your classes, but not really change open to extension. Liskov substitution principle, which holds that you can always substitute the base class for a child class, or child class for a base class, and that's harder than you might think. It's the promise of dynamic dispatch, but it's easy to do wrong. interface segregation, which talks about making sure that you don't have to deal with, something that's using a class shouldn't have to worry about methods that don't really apply to it. And then dependency inversion, which is most of his discussion, which is the idea that, I don't have the note on that. So the idea behind dependency inversion is that a high-level class should not depend on low-level implementation details. So your business logic, like a PID loop, shouldn't depend on the particulars of the fact that you're using DAC and MAX, or instruments from some of our competitors or something similar. It shouldn't matter. They should depend on abstraction. And he spent the whole session talking about that. This is the source book, Agile Software Development by Robert C. Martin. And I was so impressed with the discussion that I promptly went online and ordered a copy, and I'm about halfway through it, and it's really good stuff. I can't recommend it enough. So this is probably the single biggest takeaway for me from the CLA Summit. That's why I go, is to learn about stuff like this. So we had a couple of sessions that were really intended for the whole audience. One of them on the first day, 7x7 lightning presentation. And this is a pretty cool format. You got 7 minutes to talk about something LabVIEW. And it was an open-ended, bring us something cool about LabVIEW. So Brian Powell brought us a discussion of his very first BI that he worked on way back in LabVIEw, whatever, it was in black and white. And having to bring, to actually, we needed to go reference it again. We had to pull it into its current version of LabVIEW. Another individual wanted to talk about an application that he'd done involving satellites, and he thought that it was a competition. He thought he should win because it was about space. And it was a cool app. I've been working on space-related stuff. It's fun. And there were several others. I couldn't find goofy graphics for them, but it was pretty fun to get that whole lightning instead of sit for, you sit for a typical presentation and you've got a bunch of setup. And 5 minutes of punchline, but you got the setup. And this just stripped it down. Can you get your point across in the 5 minutes of punchline? Just a challenge. Second day, we had a group project. We divided up into teams and had to, given an API, given a set of skipping commands that we had to support, we had to write an API. And we didn't actually write the API. This was about speccing it out and what functions are you going to provide and what are you going to call them, because that turns out to be a bigger and harder problem than folks might realize. Some teams did well, some teams did not so well. Everybody had a little strife, and you had to take people who weren't used to working together and put them together and come up with something. It was a little self-serving. I didn't take a picture that had me in it because, swear to God, it's the only picture of me ever taken at a group function that doesn't show my bald spot. Yeah. We did have the annual state of the certification program. Have you all, so who here does not hold some level of certification? Okay. Speaks to me. Say what? Speaks to me. Well, yes, certification is a handy thing. I am not one of those who thinks you absolutely have to have a certification. I know there are plenty of people operating at the CLB level or CLA level who, for whatever reason, don't want to take the test. Having said that, certification is a handy thing to have. And one of the problems that the certification team has been tackling is retention. People go through the work of getting certified, and then recertification is enough of a hassle that they don't do it. So we actually lose people, which they've been trying to address. So one of the things that they did is they pushed out the expiration dates on all of our certifications. If you had an active certification as of the summit, if you were a CLD, you got a year added. CLDs are good for 3 years. CLAs are now good for 4, which is pretty cool. The other thing they did is they revamped the recertification by points program. You can sign up for that, and then by performing any of a list of activities and doing the necessary things to notify the certification team, you get essentially continuing education credits. And if you do enough of them, your research comes to you for free. So here's the link where you can go and read about the recertification by points program. I did go ahead and steal from their document just to give you an idea of what's on the list. So if you're teaching classes, yes?
Will, and if they can't hear me.
Yeah, well.
Will the presentation be available, i.e. will that link be clickable in some asset, or should we tell people how to search and find it perhaps?
It's on as an topic, wasn't it? I am such a dork. Okay, I will. So the question was, how do we make the link available to people? And I included the link to an internal page. Okay, yeah, pardon me. Well, somebody got a napkin, I can wipe this egg off my face. I will post in comments to the session, tonight's session, where you can go and link to this document. And somebody please harass me to do that if I don't do it by tomorrow. Well, I'll try to do it tonight before I forget. Oh, Fab's helping out. Okay, good. But basically, this is it. So there are some limitations. I mean, if you go, I think it's like the first time you teach a class, you get so many points for it. Obviously, the more sophisticated the class, the more points you get. You get points for attending, you get points for teaching. You get points for attending things like the CLA Summit. You get points for presenting at the CLA Summit. And that makes a great deal of sense to me because if you're a CLA and you're attending the CLA Summit, that's your continuing education. You get points for helping out, as always, you get points for helping out creating exams. That's our big pain point. And then there's some additional involvement with NI that can lead to points. And you need a whopping 50 points to recertify, which is just golden. Basically means that if you attend 3 CLA Summits, you're good. And the reaction from the community at the summit was very much wow, that just became trivially easy. And my thought on that was, if you're staying current and you're coming to summits and you're interacting with people and you're attending sessions, you're learning things, it should be easy. So,
are there no limitations on how many?
There are limitations. Presentations have to be original content. So the first time you present something on it, so Fab's presentation on unit testing. The first time she gives it, she gets 30 points because she presented at the CLA Summit. She will never get points for that presentation again. I don't know about courses. I don't teach courses, so it's not something that I track personally. Obviously, you're only going to get points for an exam question once. I don't think there are no category limitations anymore. I don't think. A certain notable exception that doesn't apply to most of you guys. But yeah, it should be. The point is, if you're staying current with your community, if you're staying active, if we can document that you're staying active, that we know naturally lead to your continued growth and your continued contribution, then certification should be a matter of filling out some paper. And that's what I got. That was the CLA Summit in the Americas. Any questions, comments, additional things you want to ask me? If not, I will hand it over to Darren to tell us all about CERN, because he was one of the cool kids. Can you tell I'm a little jealous that he gets to go?
So yeah, is this ready to record? Am I going to have to repeat myself for anything? Am I good?
You're good.
I'm good. All right. I'm Darren Nattinger. I work in LabVIEW R&D. I think most of you guys know me. I went to the CLA Summit in Europe. It was my first time ever leaving the United States of America. Thanks. And I survived. So yeah, this presentation actually mostly has pictures of the cool stuff I saw. Alan already talked about a lot of the cool technical content. There was a lot of overlap with the Euro CLA Summit. I have a captive audience, so you guys get to see my pictures. But I will talk about LabVIEW a little bit too.
You also properly use the ellipsis. That's mentioned.
I had really good English teachers in high school. All right, so this was a whole new experience for me. I was gone from home for 8 days. My wife and I have 5 children. I'm pretty sure she worked a lot harder than I did while I was gone. I went through London to Geneva. We had a free day before the CLA Summit started. I've never experienced jet lag. It was terrible. I did not know getting my 8 hours in my bed with, my pillow and my blanket, and I was completely thrown off by the time change and the new, surroundings. So I was pretty much on no sleep for this whole thing. So I got to figure out a way to fix that before my next trip. But anyway, first day of the CLA Summit, I gave my Hidden Gems presentation. Who in this room has seen my Hidden Gems presentation? All right, so about half of you guys. The other half of you guys, if you go to Google and search Hidden Gems in VI-Lib, you can download my presentation, and it's really cool. Yeah, Steven's seen it almost every time I presented it, and I presented it at least 6 times in the past 2 months. So everybody loves it. It's basically all these VIs that are already in LabVIEW that do stuff that you've probably already written. But I'm trying to give this presentation as many times as possible so people will learn that they don't, as Alan said, have to reinvent the wheel because there's already a bunch of stuff in LabVIEW you can use.
And there's a Hidden Gems palette now.
So part of the download, again, go Google Hidden Gems in VI-Lib, you'll see all of it. And one of the things is a VI package that will install a palette for you that basically has all of these things that are already in LabVIEW that are available. So go check that out. I presented that on day 1 and, of course, attended all the presentations. There weren't multiple tracks in Europe like there were in the U.S. Day 2, there were some presentations, and we got a tour of CERN. And then day 3 was kind of like an open-ended day. And then actually Stephen was with me on this whole trip, by the way, so if I make any mistakes while I'm talking about stuff, feel free to correct me. But anyway, one of our CLAs over in Northern Europe found out that Stephen and I were going to be in Europe, and so he invited us to come present at an advanced LabVIEW user group meeting in Northern Europe. So we did that on Friday. We had a free day to sightsee in Copenhagen, and then came back to Austin. So that was all the stuff I did. So here's some pictures. Again, being from Texas, not traveling very often, there were these strange tall things on the horizon that had white stuff on the top of them, and I wasn't quite sure what those were. People told me those were mountains.
And they're awesome.
Yeah, they looked really cool. In Switzerland, you're pretty much surrounded, so everywhere we went, there was mountains everywhere. It was pretty cool. The Coke bottles were measured in centiliters. What the hell is that? 20 ounces, please. That's what I understand. So Stephen took this picture. By the way, Stephen took about half of the pictures in this presentation. It's kind of hard to see because of the lighting and stuff. But this is Jeff K. standing in the middle of the street while cars are driving by, taking a picture of a statue in the middle of this French village. So thankfully, we do still have the father of LabVIEW with us.
Why did you let him do that?
By the time I saw him out there, it was too late. He was already out there. The statue had this funny smirk on its face, so I think that's why he was taking this picture. Yes,
Okay.
Voltaire, the namesake of the village that we were staying by. And then for dinner that night, we were in France. We ate at an Italian restaurant, and I had pizza that had an egg on it. And it was actually pretty good. All right, so CLA Summit Day 1. I just listed a few of the presentations here that I thought were pretty cool. If you are a CLA, that means you have access to the CLA community group on NI.com, which means you have access to most of these presentations. We got to see a presentation about how they're using LabVIEW at CERN for a lot of the applications having to do with the collider. There's this gentleman from the UK named Steve Lott. Some of you guys probably know him. He gave a presentation on all the terrible things you can deal with in your job as a consultant that everybody, I'm pretty sure all the consultants in the audience already knew all this stuff, but he was being humorous enough that it was funny anyway. And then one of the last presentations of the day was about some SQLite API that this guy was using in LabVIEW. And he was talking about the performance of it and how easy it was to use. And I had a discussion with some people afterwards wondering why we aren't all using SQLite instead of variant attribute lookups, and the main reason given was that variant attributes are native platform-independent parts of LabVIEW, and SQLite, although very useful and very powerful, the way it was demoed to us anyway was Windows only. The picture up there was the shuttle bus that we took to CERN that actually got stuck in the middle of a parking lot on a median, and I felt really bad for the driver because he was doing the whole Mike Myers, Austin Powers thing back and forth 100 times before it finally got stuck and he couldn't move it. So thankfully, we were pretty close to the building we were supposed to be at, so it was a short walk. CERN is huge, by the way. Imagine like UT campus times 20, and that's how big it was. It was massive. Okay, so the dinner that night, some raw meat was placed on the table in front of me. I was a little scared. Again, native Texan, cheeseburgers, chicken fried steak, pretty normal American food for me. So when the raw meat was placed in front of me, I was a little bit scared. I don't know how to pronounce that. But they gave us this little pot where we could dip it in and cook it. And so like the raw meat was cooked, and then you can dip it in all these little sauces, and that tasted pretty good. So,
well, and as a Texan, you want to know how to cook steak.
Well, as a Texan, I want my meat to be completely dead. So yeah, that was the fancy, authentic Swiss dinner that we got to have on day one. So that was pretty neat. Day two, there were several presentations. Again, a lot of overlap between what happened at the CLA Summit Americas and in Europe. You know, Jeff Kay giving one of his keynote type presentations. Zaki talking about the certification changes. None of that matters though, because day two was the CERN tour. One of the main reasons I wanted to go to the CLA Summit Europe in the first place. So there's an on-site museum at CERN. That's a pretty cool building. That's actually all wooden planks surrounding the building going all the way up to the top. And inside of there is a really neat museum. Outside of there were these dipole magnets. So this is not actually one of the real dipole magnets, just an example of one. There's a van next to it, so you can see how big it is. This thing was almost 50 feet long, and there's 1,200 of them along the path of the collider underground. And when the collider's on and they're running an experiment, these things get down to about 2 Kelvin. And that incredibly cold temperature is what allows the superconducting super collider to spin the protons so fast. So I thought that was pretty cool. They had that one sitting out there, and then they said, oh yeah, there's 1,200 of these things underground along the path. So there are 8 experiments around the border of the LHC underground, and we got to tour one of them called the LHCb, and the B stands for beauty, which is kind of neat, but then now we're starting to get into really complicated physics here. Beauty is a quark quantum number, and now I'm kind of wishing I didn't forget all that stuff I learned in college. But basically, the example that the experiment that we got to see was one where they're colliding protons, obviously, and they're studying the shower of the subatomic particles that kind of go when they collide. And the purpose of the experiment is to figure out why our universe has so much matter and so little antimatter. Theoretically speaking, there should be way more antimatter than there currently is. So this is one of the experiments they're doing to try to figure out why that is. There weren't actually any experiments running while we were there. I seriously doubt they do any tours while the experiments are running. The next run of the LHCb is going to be in January. So while we were in there, we actually saw lots of people just setting stuff up and technicians with giant wrenches doing stuff and getting ready for this big experiment in January. So kind of blurry, but this is a picture of the panel and the elevator that we took down to the experiment. There were only 2 buttons, 0 and -1. That's another weird thing about Europe. They don't do like floor 1 and floor B for basement. They do floor 0, which makes sense to us LabVIEW programmers, and then floor -1 for the basement. So anyway, the elevator only had 2 buttons, and I timed it, and it took us 50 seconds to get from floor 0 to floor -1. We were 300 feet underground to check out the experiment. This is the LHCb. After I saw this, so basically we were standing on a platform looking out at this thing, and afterwards I think I asked Steven or somebody, like, where are we in relation to the actual proton tube that's going underground, in a huge, gigantic circle? And somebody finally explained to me that the protons are going to fly in from this direction and then explode in this direction. So it gives you a little framework for what's going on there. And I saw C-Rio in here, so I was excited because I actually saw some NI hardware. So there's this huge rack of equipment, and C-Rio right there. And Steven's camera was way better than mine, so I'm using his picture, not mine. And then we had to go through this system of complicated keys and doors to get in and out. That's me with a frown on my face because that was the end of the tour at that time. All right, so on day 3, we did a bunch of sort of open-ended roundtable discussions based largely on like questions and stuff that had come up in the previous 2 days. Talked a little bit about source code control because what CLA Summit wouldn't be complete without a discussion on source code control. Then the head of computer security at CERN came and gave a discussion about security issues that they have at CERN, so that was pretty cool. And one of the things we talked about, people seem to have forgotten that we tried this 10 years ago, but people were really interested in getting like a really lightweight LabVIEW editor thing, kind of like LabVIEW Player from long, long ago. So we talked about that for a while. And that's all I have in here about the CLA Summit. Again, if you're a CLA and you have access to the forum, there's this transcript of pretty much 3 days worth of conversations and stuff that they posted on there. So that's pretty useful. So then, Stephen and I flew from Geneva to Copenhagen for the Advanced Lab User Group meeting. I have that picture. There were 50 people that attended. The guy that was running it, his name is Samuli, told us that there were 51 registrants, so almost everybody that said they would come came, which is pretty cool. They were almost all CLAs and CLDs, so pretty advanced users. It was Finland and Denmark and Sweden and all those countries up there in Northern Europe. There were some pretty cool presentations here. Again, I gave hidden gems at this one as well. Stephen gave a presentation on LabVIEW classes. And there were some other neat presentations, a good intro to network streams and the types of applications they're good for. A guy talked about using some .NET APIs to send and retrieve data into that Microsoft Azure's cloud storage service, which is neat. I think my favorite presentation was the one on resizable UIs. So I'll go into this one just really briefly. Writing resizable UIs in LabVIEW is a total pain in the butt. And a bunch of us have come up with our own ways to try and make that not so terrible. And this guy named Vibe Valstra, had an API and a utility where you can point the utility at your UI and sort of tag all the things on your front panel and say how you want them to resize your VI. This is like you're statically editing your VI, saying how you want things to resize. All you have to do at that point is take a single VI and drop it on the diagram of this resizable UI VI. And this thing's a brat VI, so it controls how the things on the front panel work. And that's all you have to do. So once you've set up the UI with this tool, you drop a single VI on its diagram and now it's a resizable UI. It's really nifty. I don't think he's made it available yet. Like in the presentation, he kind of waffled a little bit about whether he's going to make it free or post it for sale or something like that. But it was a really cool utility for making resizable UIs. So if I find out anything more about that, like if he ends up posting it on the Tools Network or something, then I'll post to our group. So what Darren trip wouldn't be complete without a coding challenge, right? So they decided they wanted to pit me against somebody to see who's the Northern Europe's fastest LabVIEW programmer. So they had a coding challenge. This one was a little bit different from the one at NIWeek. Instead of pure speed, this one was speed of coding combined with performance of your code. So part of your score was how fast you finished, and a part of your score was how fast your code ran. And the other guy actually finished a minute before me, which was a little scary. But my code ended up running 3 times faster than his, so I won the coding challenge anyway. But all right, so in Copenhagen, again, I'm not used to seeing big, fancy, ornate, old buildings everywhere, and that's totally what Copenhagen is. I'm used to seeing, what Texas looks like. So, yeah, this was this huge church that was right by our hotel, and multiply that by 20, and that's how many big, fancy buildings we saw. But we were in northern Copenhagen, so we were right by the shore. And I'm from Corpus Christi, Texas, and other than it being cold here, being by the shore and seeing the water felt like I was at, back in my hometown. So, when you're not around the fancy buildings, you're just kind of on an ocean front. I thought that was interesting. While we were walking around, we heard music off in the distance, so we ran off to see what it was, and we happened to see the changing of the guard at the Queen's Palace, so that was pretty neat. I leaned up against the building, and a security guard told me to stop doing that. And then that night, we went to the Tycho Brahe Planetarium, which we didn't actually get to go into the planetarium part because I guess we didn't show up at the right time, but they have kind of like a museum there, too. So among the other neat things they had these big old meteorite chunks that had smashed onto the Earth sitting on these pedestals, so we got to see those. All right. Any of you guys have ever seen Pulp Fiction? They talk about the little differences. And one of the examples they give is how they love to dip their French fries in mayonnaise over in Europe. That is 100% accurate. I got teased when I asked for ketchup for my French fries. Multiply that by dozens, and that's how many little differences I noticed while we were over there. The bathtubs, like they're this high, so you kind of have to like step into them like this and almost slip and fall and break your neck. I'm really not used to interacting with people who may not speak the same language as me. So one of Stephen's tricks I noticed was that as he was walking up to somebody, he would say hello, and they immediately knew that he was an American, and they could then, craft the way they spoke to him accordingly. So I started, before, as I was walking up, I would say hello a little sooner than I normally would, and that would communicate that, I was a dumb American who didn't know any other language. So I Skyped with the wife and kids a lot. My parents are total, old timers. They don't have iPhones or anything, so it's really cheap to call a landline on Skype, I found out. So I was able to talk to my parents even though I couldn't, video chat with them or anything. And, one of my main pieces of trepidation was the food, and it turned out that most of the weird new food I tried was pretty darn good. CERN, in case you're wondering what it's like to be there, it's like being on a college campus. All the buildings, you walk in, in your engineering school, you know what it smells like? That's what CERN smells like. You walk into a building, you're like, oh, I'm in an engineering building. Exactly the same, only, like I said, 20 times bigger than UT. I went to UT, that's why I keep referring to it. And there's professors and grad students everywhere. They just all speak 20 different languages. And before my next international trip, maybe it's CLA Summit Europe 2014, I don't know, or 2015, I got to figure out how to solve the jet lag thing. And I know I'm being a wimp because, traveling to Japan or something, it would have been twice as worse, right? But still, I couldn't take it.
I have your solution.
Yeah?
Yep.
What is it?
If you're traveling east here to Europe, then you can leave in the evening. And I can work out the logistics with you offline, but effectively, if you can crash for just a few hours on that flight and get out the next day, you'll be in sync. Done it that way. If you leave in the morning here,
you have to do that, and you have to convince the airline not to make you 12 hours late.
Yeah, I didn't mention all of the delays we had in getting on our flights. I tried to sleep on the plane.
But the key is you have to leave in the evening U.S. time. If you don't leave in the evening U.S. time, you'll have too long a time effectively to gut out, and you'll get screwy.
Yeah.
That and you left 3 days later than you should have.
Yeah, that's true. But I really enjoyed getting back to Austin. This is an aerial view of downtown Austin as we were leaving or coming back.
That's as we were recording.
Oh, okay. So pretend it's when we're coming back. And that's all I got. So any questions from you guys?
How long was the tour, sir?
It was 4 hours long, I think. Yes.
Did you carry any animosity with you because we lost for conducting the glider in Texas?
I wasn't angry at them. I was angry at the dumb politicians in Texas. Anything else? All right. Thanks, you guys.
So Fab just asked for the presenter to repeat questions. They don't know what's coming through, I suppose. Yep. She is traveling for work, I believe. Not sure where. United States? I think so.
Oh. Oh.
Detroit.
There.
All right, so this is easily the weirdest presentation that I have ever given in my time presenting. It's interactive. There will be parts where I'm going to need your assistance. The first time I presented this, I presented it to a room full of people who didn't really speak English as a first language, and that was interesting. And then the next time I presented it was in the Tech Theater at NIWeek 2012, where you can't hear anything. So you're kind of like the first audience that might actually get all of what's in here, and you can tell me whether it was, actually worth it. So my goal for a number of years has been to try and explain why data flow is such a nice paradigm and why I spend so much time working on improving this particular language instead of going and using my talents on something like, improving Dart or Go or Lisp or languages that have my attention from time to time that I'm interested in. LabVIEW has a lot of nice things for it, and one of the biggies is this data flow. And I've looked around for a long time to try and explain what we get from data flow and how it is that it becomes so powerful, especially as we get into these multi-core environments. And so this is my attempt to do so. This is a potato on a pedestal. Or is it? If we remove the pedestal, this is just a potato. Now, a picture very similar to this was on one of my friend's iPads. She was cooking a recipe in the kitchen. My nephew, age 5, saw it. And he asked a very good question. He's looking at this iPad, leaned up against the wall as his mother's cooking, and he goes, "What's holding it up in the air? Is it a magic potato?" Because as far as he could tell, there was nothing holding it. It wouldn't fall. But look, it looks like a potato. And I explained that it was just a picture of a potato. And if we wanted it to fall on the screen, because he pointed out that they're on television, things would fall and everything, that I would have to write a program to actually animate this. Some software that would actually drive this and update the position of the potato and make it move down the screen. My nephew, being a very bright kid, even at age 5, is getting dumber as he approaches his teenage years. He looks at me and says, "Okay, so where's the computer that makes real potatoes fall?" Which is an interesting question, and led to something of an existential discussion with the 5-year-old, which has continued on now until he is now on the brink of turning 12. When we consider the universe, we can represent the universe, in theory, something like this. We could lay out the whole universe as a string of zeros and ones, and we could have some computation that takes in one state of the universe, turn the crank, compute the next state, and then render it on some screen. Let's call it reality. And we get very used to, all of us, building computer models to simulate whatever it is that we're doing, be it a computer chip, rockets to space, a computer to simulate a computer, because you've decided to build a virtual machine. We can nest these as deep as we want to go. We all get used to sending the model that direction. But when we started talking about this potato and the relationship of the potato to reality, I started using analogies that went the other direction. And the more that I had that conversation, the more I kind of realized that you could reverse the analogy a lot. So between one clock pulse to the next, we get this large computation going on, and we could do this for everything to compute its next state. Can we then use the universe as a model for software? And when I turned that equation around, I suddenly found myself able to lay out a better description of why data flow really works. So, I am reliably told by the internet, which knows everything, somewhere, that Snickers is the single most popular food on the entire planet, outselling the next candy bar, the next whatever, by orders of magnitude. If they are introduced into a culture, they become the #1 selling item within a year. I am therefore hoping that people in here enjoy them, because if you don't, this will be a very bad presentation. We are going to have various ways of sharing this candy bar. So I need 2 volunteers from the audience. 1. I'll pick somebody. 2. Come on up.
You get candy bars out of the deal. It's okay.
Yeah, well, maybe. We'll see how they do. All right. I'd like you two to share this candy bar. Go ahead, open it, deal with whatever you would like to do. Find an appropriate way to share this candy bar. Or, All right. You two may now sit down. Hey. Did they share the candy bar?
Some definition.
What do you mean no? No longer a single candy bar. Exactly. They each took part of it. All right, I need 2 more volunteers. Over here. You.
Okay.
Now again, share this candy bar, no breaking it.
Ooh, this is going to get sexy.
We both have ownership of this candy bar.
Ah, okay. Joint custody. Okay, that's one solution.
Just holding it right
You may go. Several people in the audience at various points suggested the Lady and the Tramp solution. I heard this is going to be a sexy comment. There are other approaches here. As a matter of fact, there are a whole bunch of options. So, we had the break it in half option. We had the time sharing, this co-ownership, back and forth. We have simultaneous access, both of us chewing on it together. And we have morphological integration. I'm surprised none of you thought of this one. This is where you simply combine your cells into a single eating repository and take in the data at once. In software, this is viable. In biology, it's just trickier. The point of this slide, in addition to being very amused at the news that are here, is that all of these ways of sharing the candy bar apply equally well to sharing data. And by equally well, I mean equally as poorly. If you're trying to chew on the same candy bar at the same time, your processes bump into each other. If you try to blend your 2 processes into a single monolithic piece of software so it can chew on the data at once, you end up with other nasty bits.
Is that a transporter accident?
Yeah, or the movie The Fly. If you try to do time sharing, you end up with these things called mutexes and semaphores and custody battles and judges getting involved and people declaring that's my data, no, that's your child. All of them have drawbacks. And ultimately, what you start to realize in the computer, as in real life, is you really would just like to have your own data. Like you'd like to own your own source code and not have anybody else who goes in and mucks with it. Just be able to have your own house, your own stuff. Gosh, isn't it nice? You just, you can get by. All right, I need 2 more people. 1, 2. Come on. All right. So we can think of eating as making changes to the data. That's sort of a write operation. There's actual processing going on, modifying of the data. We're now going to just talk about read operations. I would like the 2 of you together to read the ingredient list.
Did you bring your glasses? There's morphine phosphate.
Feel free to make it up as you're going along.
Sugar, yes.
There you go.
There's eggs and flour in there. Yes.
Natural flavoring.
Yes. Ribosome 7, I think.
All right.
Maybe that was the movie I saw.
One of you can take that, head back to your seat.
I racist.
All right.
More than I
So here we have them both reading at the same time from the same piece of data, right? Right?
Yeah, the photons had to come off the paper at different times.
Heads close together. These are the various approaches I've seen doing this. One person can read aloud, the other, back and forth. You could put it up on the screen, and you could have read the one that was behind you. Aha, see, then you don't need your glasses. You get into all sorts of weird conversations, though, even when you're just reading. Like, who throws away the wrapper? What if the other person is still reading it? Where does this data live? What's its lifetime? Why is it upside down? It's easier if everyone just gets their own copy, because then we could just each read it on our own. And someone pointed out on the photons, all of the data sharing is an illusion. These two processes don't actually use the same data. Something had to make a data copy at some point. In fact, I have a side hobby is reading weird theoretical physics papers, especially when they impact on computer science, including my all-time favorite, the proof that if P not equal NP under classical mechanics, then P not equal NP under quantum mechanics, and all known quantum and quantum gravity fit theories. Which is a really depressing thing, which basically says that if we can't make it go fast in a stupid slow computer, then all the special physics in the world will never help the algorithm go even faster. Like doing things on the cusp of a black hole and everything. Very depressing. But along the way, one of these things that I found is essentially, at some level of hardware, data gets copied, or it can't be consumed by two separate things. Energy doesn't end up in the same place. We may quantumly entangle electrons, but there are two separate electrons, no matter where we're sending them. That's a separate discussion. As I said, if you've got a paper on this topic, I'd love to see it, because that actually has the potential to be a substantial computational breakthrough if you've got such a thing. It turns out that at some level of your hardware stack, you're going to make a data copy. Whether it's you're copying it in registers, and you're doing the copy all the way back in memory, or you're making the copy back when you made duplicates of the file on disk, or you made a copy when you sent it across the network because you've got things distributed. Somewhere, no matter how much you optimize and how much you simplify, somewhere there's a data copy being made if you've got two independent processes. When we start looking at software, we sort of pick what level we're going to be operating at. Every piece of software is kind of, okay, I'm operating here in the operating system stack. I'm operating here in the distributed network world. We kind of ignore all of those details. And we're just sort of saying, within whatever domain it is that we're working in, operations on it. So this is what I define Dataflow as. Is a model of, and a number of other people define it this way too. Like I defined it, but this is my favorite way of phrasing it. The model of parallel computing represents as dependence graphs where each operation waits until its input value is available. By declaring dependencies, the programmer allows the compiler to calculate the best data sharing and data lifetime. There's 1,000 ways you can implement variations on this theme for different programming languages. Most data flow languages out in the world are something that are called asynchronous data flow, where nodes will fire whenever they get their data, and they aren't necessarily waiting for the upstream node to completely finish. You can think of it as that for loop with the indexing tunnel. Well, instead of having an indexing tunnel, it just keeps sending the next value down, kind of like you get when you start doing pipelines in your FPGA programs. LabVIEW is a synchronous data flow. There are a number of other interesting ones. NIMO-Tunes, N-I-M-O-T-O-N-S. It's a programming language out of Spain. I absolutely love this thing. I didn't even know about NI or LabVIEW when they built it, and it's beautiful. It's animated graphs. The entire program moves through and slowly simplifies as it emits finally down to a single constant. Beautiful to watch the execution highlighting. Tons of different models that you can find this. When we start compiling C++ programs, C# programs, Java programs, C, Lisp, a lot of the compiler analysis goes into the data flow through these programs. We spend a huge amount of time trying to find these code paths. And that tells us that there must be something of interest in understanding the flow. Is there any way to turn that on? Whoever's on the other end, can you mute your microphone? Thank you. Or finish dinner. I realize those Snickers bars are probably making you hungry. So there's clearly a reason that that these people are interested in finding these data flows. And so that suggests, there must be value in it. So let's kind of take a look here. This is a LabVIEW program. We've taken an array, and we've got two readers. Is there a data copy? Where? At the branch of the wire? Well, the correct answer is, you can think of there as being one. There is certainly a data copy because I said there's always a data copy. And the question really is, are we making a full copy of the entire array, or is there some portion of the array that we're copying? And really what the answer is that the copy in this particular case, we're not creating a full duplicate of the heap of the array, actually duplicating it in memory. There's some cache level copying going on at the processor level, and instructions coming through into registers. But the big copy, the expensive copy that everyone worries about, where we duplicate the array, that doesn't happen. And the reason that doesn't happen is because LabVIEW looks at this and says, hey, this is a reader, and that's a reader, and it's reading the array. And so there's no reason to make a full copy of the array in memory. We'll just let the back-end caching systems for that are handing it off to your 2 cores of your processor, we'll let them make a duplicate. And when we we can just reuse the same heap section. So that's the what the LabVIEW is doing by looking at where the data is flowing. It says, I can avoid making a data copy. Now, you get a more complicated situation. You've got a search up there, and you're going to delete from array here. Is there a data copy?
You need new memory for the modified array, for sure.
You need new memory for the modified array for sure. Okay, so let's phrase this as, is there the big data copy? First of all, did we duplicate this array?
Is the compiler smart enough to recognize search and delete?
Aha. And the answer is yes, it is. So LabVIEW, because it looks at this data flow, and what it does is it looks downstream and it says, really, we don't really care when those 2 values really get filled in because there's no timing requirement. And for anybody who's outside of the sub-VI, they're going to get those values at the same time because the node returns its outputs all at the same point. So we're just going to treat this as one clump, and the compiler is going to make the decision. I'm just going to run the search1D array first, let it finish, and then I'll schedule this. And the reason it makes the decision, it says the time needed to make the copy of a large array is so big that it actually, it's better to just serialize the 2 operations rather than taking advantage of the parallelism. Now, this is a very simple example. There are plenty of more complex ones where LabVIEW compiler churns and churns and churns and would decide to make a data copy or not. And then the delete from the array, that happens in place. We actually don't have to allocate new memory. We just shrink the array. But the point is that it's looking at all of this analysis and figuring this out as to whether or not to drop these data copies in or not.
If it was an insert, would there necessarily be an allocation then because it would grow the array, or might there be space sort of that made that less expensive?
In a trivial case, yes, there would definitely be an allocation for the insert. In something like an insert that occurs inside of a while loop, it may be that we looked up ahead and we said that insert's going to happen a whole bunch of times. Let's allocate a bigger block and then just use chunks of it until it's, we fill it up and then we'll reallocate. We use something called amortized growth in those cases. Now, here we have two writers. We're both going to make a modification in that array. there a data copy? The big data copy. You'd think there would have to be. And you'd be right. LabVIEW cannot do the impossible. This is indeed the two mouths both trying to chew on the same candy bar, and somebody's got to get their own data copy if they're both going to actually swallow the same data, the same thing. It just doesn't work to try and have it together. Now, we have two writers both in loop. Is there a data copy? This one's kind of cool. Partially right. Actually, there's another allocation, but we don't actually bother making a data copy. Because what we do is we say, look, this is actually a read operation that can happen. So as long as we schedule one loop to be slightly faster than the other loop, we can read it through. It starts cheating. And it really gets interesting once the compiler gets really turning on it, and it fuses the two loops into one because it says, hey, those both got the same I count on them, and the destinations downstream are both being used together, so we're just going to blend that into a single for loop. I'm highlighting all of these slides. By the way, this is the morphological integration into becoming a single process. I'm highlighting all of these because one of the things that I've talked about is we're trying to get a better understanding of this data flow and how does the compiler leverage all of this data. People keep asking me, well, what's the optimizations on this block diagram? How fast is this going to run? Is this going to be a better performing thing? We have passed the point where even the people on the LabVIEW team who work daily with the compiler can only tell you in the most vague terms what's going to happen to any particular VI. Because... Oh, okay.
The question is, does what we just discussed work the same way for RT targets?
In a general theoretical sense, yes. Any particular optimization, as I said, may or may not apply. The compiler has gotten smarter than any of the people that work on it. That really started passing a threshold in 2010. We've been adding optimizations to LabVIEW for decades. But in 2010, we really started going to town on the optimizers and some of the new, keyhole passes and LLVM and all of these different tools, to the point where what actually happens on any given block diagram and what really, all of the data that it's taking into account is far more than most of us can do. It's usually possible if I sit down with a given VI to reverse engineer it, but it can take hours to figure out exactly why certain things happened and why they lined out. This is what happened with C code decades ago. C++ code, most of the other programming languages, to the point that people stopped writing in assembly. But what's interesting is every one of the optimizations that LabVIEW is taking advantage of is driven, even when we start talking about LLVM and the optimizations that are happening at the actual assembly level, is driven by the ability to recognize where the data is flowing. And it's the fact that we know things about how the data is used in the program that allow these optimizations to be applied. Because if these two were flying off to completely different parts of the code, such that they've got downstream dependencies, you can't really afford to fuse them together into a single loop, because that binds their timing together. And that would cause these two other downstream processes to not be able to kick off until both of them are ready to go. We are driven by all of this data coming through the process. And the interesting bit is that means that it becomes very important that more than any other optimization that you guys think about doing, I've got to make sure I use build array inside, not use build array inside my while loop, but I need to use initialize array and fill it with stuff and move it in. There's all these rules that a lot of programmers have built up over the years that they have to remember to get better performance. And some of those are still very important. I'm not going to knock a general knowledge of things that are more performant. But trumping every single other concern is, are you maintaining data flow? Are you continuing to push the data through wires as much as possible? Data flow works fundamentally because compiler prevents you from bumping noses as you simultaneously eat both ends of the chocolate and from pulling the candy out of someone else's mouth while they are still chewing. This is what the compiler does, is it looks at all of this blocks of data and where you're sending it, who's going where, and it says you don't have to worry about doing your own morphological integration. You don't have to worry about putting your own semaphores down. You don't have to worry about trying to do your own timing. The compiler can figure it out and can do a better job than most of the people who even build the compiler these days because it can follow the data flow. Now, it is with a certain amount of sadness that this is logically and physically impossible. You cannot write this in LabVIEW. You read from disk into some shared storage, and you are going to access that shared storage in a read-only format without making any data copies and without making one VI wait on the other. There is no mechanism for writing this VI in LabVIEW. I challenge you to try and do it. It's a fun thing to try and walk through. It's a fun thing to sketch up new possible syntax that you could apply to make this possible. The number of people I have seen try to do this because they just don't want to run a wire from their read into these two things is kind of funny to watch, actually. But people try. People try all the time. But the problem is that without a wire, LabVIEW looks at this diagram and says, I don't know the timing of that central data store that you're reading into. You read all this data off of disk, and it's sitting here, and anyone could need it at any moment. So just because one person is needing it, I might need to have a second copy available. I might need to have timing windows. As soon as you are no longer running things through wires, you're going to have data copies and waits that are otherwise unavoidable. You can do this in C++ and Java. Why? Because they have these things called references. And they don't follow a data flow paradigm. They say, congratulations, you are responsible for your own data synchronization. You have to put in place your own mutex code. You're going to have to spin up your threads. When you say it's an appropriate time to spin up a thread, you have this fairly hefty burden of managing a multi-core system. Dataflow says that's the compiler's job. It's an automatable task. And I don't know about you, but the more years I work on LabVIEW and the more years I spend writing the code that builds LabVIEW, the more I am tired of writing the code that builds LabVIEW when I'm in one of the non-G parts. It's a real pain. We have a never-ending quest to share data between processes. This is a slide that has been posted many different times and is wildly out of date now because there's at least several more that have been discovered and posted. Different ways of sharing data, sending data back and forth. There, however, are different types of things embedded in this list. You cannot write this in LabVIEW because the compiler cannot prove that access from independent VIs is not going to collide. Either each VI gets a copy or one waits for the other to finish. And we have never introduced into LabVIEW a construct that allows you to say, look, I'm going to declare unsafe code here, code that the compiler cannot prove is correct, and I'm just going to do whatever it is I want to do in here. We've never introduced such a structure. The closest you get is you can make a call out to a DLL. And if you want to write your own DLL in C, C++, whatever, build it up and call into it, that would be a way that you could say, hey, inside the DLL, I'm going to read into a handle of memory, and I'm going to allow two calls simultaneously into that DLL that will both pound on that same block of memory. But within LabVIEW itself, we just don't do that. It doesn't matter which of these processes you use. Go explore them all. You can't get this to work. Okay. Somewhere around, I think I looked back through my notes, somewhere around my 2003 NIWeek presentation, it was the first time I used the phrase Dataflow safe in a presentation. It wasn't until 2010 that someone pointed out that I had never actually defined this term. I just would refer to things as, oh yeah, that's Dataflow safe, or oh, that's just not safe with Dataflow. And they said, you should probably define this at some point because it's a really weird set of things they had actually, this one customer had actually kept track of things I had declared safe and not safe, and they're like, I can't see what's in one column and what's in the other. We've been talking about this data flow. We've been talking about, how do you eat the candy bar, and realizing that, no, you got to come up with things that I'm going to take a piece of data and it's mine. And if I'm going to give it to you, it'll be yours. We don't try this sharing thing. It's not a good process. So things that are data flow safe mean the data is usable by one and only one process at a time, with a clear handoff from one process to the next. Now, I'm using a very broad definition of the word process, because a process for me is an individual add primitive, it's a while loop, it's an entire VI hierarchy that's running. At whatever level of the software stack that you happen to be operating at right then at that moment, it is a computational element. And there should only be one computational element chewing on any given memory address at a given time. All of the by-value types, when you actually run a wire, by-value wire from one node to the next wire, that's data flow safe, which is good because we do a lot of that. And if that wasn't data flow safe, we'd have problems. But those by-value types, if I do a +1 node and the value comes in, the +1 node operates on that data, and then it passes it downstream. Now the next node down here can do some operations on that data. It's not like, oh, the plus node goes, wait, let me pull that back and let me do some more work on it. Really what happens, though, when you start getting some of these sub-VIs that are talking to these LV2 globals, or that are talking to databases and they're both hammering on it, all of these references being shared back and forth, is really the node saying, okay, we're both working on it. Oh, hey, let me borrow that for a moment, modify it. Here, you can have it back. But beyond wires, the Perlian by-value type, there's some other things that are data flow safe. Directed queues. So if I have a queue that I in-queue here, and I dequeue somewhere else, and the data is going in one direction, is flowing, that's data flow safe. You contrast that with the single element queue, where somebody creates a bounded one element queue. You've all seen this trick, because we all did it before there were data value references. Create a single element queue, you put a value in it. Now everybody over here, he's going to dequeue an element, modify it, and then enqueue it back in. And while that queue is empty, somebody else can't dequeue it, and they sit there and wait. It acts like a mutex block. That's really two people both trying to share that same memory address of that one element that's in the queue. We later came along and we created, data value references to better solve that data sharing problem, and they're better than single value queues, but there's still data flow unsafe. Action engines, functional globals. So you take an uninitialized shift register and a loop that executes one time, or for those of you who are able to read such diagrams, you have a feedback node on it. The feedback node syntax bothers me because of the place where you put the initialization code. It's just wrong. There's an output there. That initialization code should run every single time that diagram executes. It's poor data flow syntax. I'm sorry. For the electrical engineers in the room, you just flat got your hardware wrong. Fix the hardware. And by that I mean change the physics. But you have this uninitialized shift register that remembers call after call what happened in there. And people are like, oh, that's the way to do good data flow, data storage, and have state and all. And they're kind of right. When you use it as a functional global, meaning that you have an operation for get the value and set the value, then you're no different than a global VI. And I've had people get angry at me for telling them this. Oh, I would never use a global VI. I always use a functional global. This is worse. It has all the data copy overhead of the global VI and the processor overhead of the actual block diagram. If you're going to have an action engine, though, that's good. When an action engine is, it says, I don't get the value out, do some work on it, and then put the value back in. The action engine says, I call you and I say, I'm going to tell you to do something to that value. And you're going to do it, and you're going to keep all of that data sealed up inside of you. And somebody else can call you and say, here, do this. And we're passing information into that thing, but we're not trying to copy the value in and out. Same basic architecture on the block diagram. They look almost identical. totally different semantic. And one of them falls in the category of Dataflow safe. User events and the notifiers. They are kind of like a directed queue. You put data into the generate user event, and it pops out at a whole bunch of user events. Gets forked, gets copied. Everybody has their own instance of it. Notifiers, same thing. I do a fire event, a fire notifier. All the way for notifier nodes get their own instance. Shared variables. Shared variables. They're bad for other reasons. They don't just break Dataflow, they break me. They break LabVIEW. Okay, you don't use global VIs, right? Shared variables are universal global. They're not just available to any VI in your process. They're available to any process on the network. I'm like, who built an architecture around a wide open variable? National Instruments. They have their uses. I'm aware of that. That's why we have them. We also have global VIs because they have their uses. Because sometimes theory falls to this thing we call practical business reality. But practical business reality is for is your last resort. It should not be the first thing you reach for. Because if it's the first thing you reach for, you end up with some really nasty code and an ID called in to debug it. And then the unforked references versus the forked references. So data value references. You put a piece of data in, and at some point you call the lock and unlock pairs on the in-place element structures. If you never fork that wire, that data value reference wire, then it's basically a by value thing traveling down the wire. And you hit the unlock and you do stuff with it and you go on. And you're sitting there going, well, that would be pretty useless to, all you're doing is shoving some data into the DVR and then you're treating it like it's a by value type. Why in the world would you bother to do that? Well, what that particular trick can buy you is things like it guarantees LabVIEW will never make a data copy. And if you're working with one of those gigantic data structures, they're
sticking a DVR if you want to move it around.
Exactly. LabVIEW, when it analyzes code, it's got this whole weighting function. It figures out between, I could make a data copy or I could do some extra processing. And sometimes it says, look, the average case out there is that it's better to make a data copy here. So I'm going to put some data copy code in rather than, make it a single. And sometimes you're like, no, I'm going to have very large data here. And so you put it in a DVR to make sure LabVIEW never makes the choice to copy it. And all it is you're just moving around that little 8-digit number, hexadecimal, and not doing it. What you lose is some of the ability of LabVIEW to optimize it because you've said, I'm asserting I want you to never make a copy of this, so do whatever else is necessary to provide those accesses. But it does fulfill the rules of Dataflow safe, and it's sometimes a good idea. Working the reference and using it in lots of different places, now you're back to Dataflow unsafe. This is not me saying don't do any of the things in the X column. This is me saying prefer the first column. Look to the first column whenever you can. When you're building your architectures, when you're designing your VIs, the first column is going to get you better performance, is generally going to get you better maintainability, and generally has a lower bound for just the amount of code that you have to write. Take a look at it sometimes. Compare some of these back and forth. You find that you generate more code when you're compensating for the lack of the support that the compiler gives you when you can stick within Dataflow. So, this brings me to some rules. To work within Dataflow, run wires whenever possible. If you can put it into a wire and run it between two nodes, that is always better than just about any other solution. These are generals. Steve Watts has a beautiful presentation on why your top-level VIs should have exactly one wire running between them. That's the air cluster. And he is, the inspiration for. He invented LabVIEW component-oriented design, and this is the work that I based all of the work on LabVIEW classes off of. He's absolutely incredible in a lot of his things, and when he says that there's times to not run things in wires, you have to listen to it. But in general, You want as much as possible to have in the wires. This is a principle to keep in mind as you're writing your code. VIs execute, data is passed. There is no run button on a control. They're here. They sit here. You start trying to think of your data as something that's alive. You start thinking in terms of, I'm going to shove this value into a local variable, and then I'm going to toggle a switch on my front panel because it's the next control, and that's going to write it out to a file. And that works. And I debugged that once. But things become more complicated the more that you try to think of the data as a process that's ongoing. Now, if you're building a simulator, the lines get murkier because at that point, the simulator is a process that is an object that you're passing on a wire. That's just weird. But for most of you who are working on general data and regular data objects, build your data as the things that are going to be moved around, and you write VIs to do whatever the processing is. Announce instead of request. This is the request version. Tell me X, I'll wait. And this guy says, okay, I'll get there, hold on. And I'm sitting here waiting until you give me this. Versus, I'm going to be busy doing some stuff, and he announces, X is ready, and I get around and, oh, okay, good, then I can go do that. The announcing version is better than the make the request and come back version when you're trying to maintain data flow. That action engine is sort of me saying, I need you to do this. And then I can, it just sort of goes in, and he does whatever he does. I'm not waiting for a response to come back. Better one is when you start talking about producer-consumer queues. I'm a producer, I put some data into a queue, I announce, there's more data available. The consumer picks it up and he works on it. The consumer could be doing lots of other things while he's not checking the queue. The more you can kind of follow this paradigm, the more your code stays within Dataflow. I don't have the VI set up, unfortunately, to do that little demo. Well, no, I do. I forgot. No, I forgot. This is that demo. Okay. I need 6 people. I'm thinking this was the VI demo. This is not. Raise your hand if you have not been in here before. If you've not come up here before. 1, 2, 3, 4, 5, 6. Andy, you're here. Alan, you're in the middle. Everybody else kind of fan out on either side of Alan. Oh, yes. Don't sit. In a moment. 4, 5. Okay. Stand up. So, I'm going to take these candy bars, and I'm going to hand one to you. I want you to look at it, verify that the spelling is correct. If it is correct, pass it to the person next to you. If it's incorrect, throw it over your shoulder. After I give you the last candy bar, sit down. Okay? You at the end, if it's good, just set it on the ground. But again, if any of you notices a mistake, throw it over your shoulder. Okay? What? Just the name. All you're doing is visual inspection of the name. Yes. All you're doing is visual inspection of the name. Okay? Ready? Remember, sit down after you're done with the lab. Did I tell you that was take a Snickers and go back to your seat. Just sitting down, I had to pause while I went back to the box to get some more Snickers. That isn't the signal that you're done, just because you checked my hands and my hands happen to be empty. For the love of God, people, please stop using the Q status primitive to stop your loops. It's a race condition. The queue is empty. I must be done. No, the producer's just slow. When you have communication channel, and you're doing any sort of producer-consumer, or reading a DAC channel and processing it through, data going from your FPGA up to your RT chassis, signals coming from the host back down. I don't care what it is. This is a hard and fast rule. Embed your stop signals in the communications channel. Do not try to have a separate communications channel that is going to broadcast the stop separate from the data. Do not try to have the guy use meta information about the channel, like is the queue empty, to determine whether to stop. Put the data in, the stop signal in with the data. It's a cluster. I know. Oh my gosh. Now it's not just a double, it's a cluster of 9 bytes. So that's going to just blow everything to hell. No. You will solve, I don't know how many race conditions, communication, shutdown errors. The world is a better place when you say, there's data and there's more coming. There's data and there's more coming. There's data, more coming. There's data, and this is the last piece of data, and you can stop after you get this one. I've debugged many of these. I've been called in to help people debug these. I'm tired of it. Stop. That's all I ask. If you get nothing else, remember number 4. And number 1. Yeah, those are good too. Okay, really, remember this slide. I'll wait. Okay. So, this is my attempt to kind of bring all this data flow ideas back together. And yes, it is a magic potato. Any questions?
Where is the computer that runs the potato?
The computer that runs the universe? True story. As a senior in high school, we had a freshman in the computer lab. Seniors ran the computer lab. It was the job of the upperclassmen, juniors, and seniors to defend the lab. Freshmen and sophomores attempted to infect it with viruses. We actually had that as an arranged thing. That was how we learned computer security. So we would give the freshmen a hard time, and we convinced one kid, or we tried really hard, that he was just a hologram, and then the whole world was just holograms. And there was only 6 people, all of them who happened to be upperclassmen, who were only real people in the world. We were on the holodeck. And we showed this kid his own source code one day. We had a big printout of it. And, this is the subroutine that you're running right now. See, it's bewildered. So, we in that point, we said that the CPU was just on the other side of the wall. Constantly, wherever he was, the other side of the wall was the CPU. Because it was just the local hologram simulation.
And when did he blow his brains out?
The day that we made the vice principal disappear. One of our guys said, I can prove that it's just a holographic simulation. I've just deleted the vice principal. And the whole senior class was in on pretending that they had no idea who this guy was. Great. That poor freshman.
Only use your powers for good, Stephen.
We did. He's now an expert in computer security, and he's got a damn good living. So. Anyway, so yes, the CPU is on the other side of the wall. Anything else? Any questions? Anything you got out of this that besides candy, that you think is valuable or that you learned? I think I've done something similar to that. That's usually more Rob's bailiwick than mine. But yeah, I've done a few of those.
Can you repeat that question for the group?
Oh, yeah. Haven't I in the past done a presentation on compiler tricks and stuff? I think I've just borrowed a couple of slides. I've never done the full, I don't think I've ever done the hide the dots presentation, for example. there's different ways of doing that. So if you've got a channel of integers, a queue of integers, and you're sending integers, and 0 is never a valid value, sure, use 0 as your sentinel. But frequently, just with doubles, sometimes you can use not a number as your sentinel. But often there's no way to have a sentinel value. There's times when you're sending a queue of Booleans. It's really hard to have a sentinel value. That's assuming your queue doesn't go dead. But see, that's an error case. See, that's a whole different thing. That you handle differently. And then you know whether it's an error, whether you intended it to be an error.
So there's a lot of good stuff in there. One thing that talked about that caused me some internal was what could you define for us a few sentences? What is an action engine? Because it's not an official term, but I think that word gets used back and forth a lot.
Good question.
Okay, what is an action engine? An action engine is an uninitialized shift register on a loop that runs once, a case structure inside of it, and an enum of actions. And
For string?
an enum of actions.
Maybe that's not an action. It's okay if it's not.
If you need strings, it's not strings, it's an object. And the case structure goes away, and at that point you have a dynamic dispatch method, because at that point you're plugging in functionality, and you've got an open-ended set. So if you've got a fixed set, it's an enum. If it's open-ended, it's a class hierarchy. If it's just a string set, you're just asking for misspelling. That's my opinion.
I agree in principle, but I think the other competing factor there is the amount of code that you have to write and maintain in creating classes ends up floating a bit, and at times I think it's maybe not worth it. But you also want the flexibility of open.
Others are able to have other opinions. That's true. I mean, that's the beauty of being architects. We're all right. And those of you who aren't architects should follow all of us.
In every application.
In every application, always. Yes. Yes.
Or you're doing it wrong.
So I don't know if any of you saw the post on Slashdot earlier today, but it caught my attention. The guy wrote an article explaining why programming sucks and how hard it is as a job. And he's like, programming by yourself is about building beautiful snowflakes. But if you put one other person on the team with you, even just one, now it's about figuring out why your snowflakes are all urine and where is the cat.
Yes, but when you're doing it by yourself, all you're making is special snowflakes. Try to avoid that.
Sometimes. I can open source special snowflakes. But I'm coming back. Don't get me to tell you about my Ancora. The idea that we can basically build these action engines up, you're giving it an instruction each time you call in, and it's going to do something to the data that's sitting in that initialized shift register. So, and you say, update yourself with this information, update yourself with this information. The classic one is that it's got a giant array of, like, your database in it. And you say, add an item to the database, delete an item from the database, tell me if this item is in the database. So you can have information coming back out, but you're not copying that entire chunk of information out. It's more that you're getting just a bit of data. It straddles the line there, as far as being absolutely data flow safe, because you're not pulling the whole block of data. You still have obviously the timing constraints there that are, you don't have two VIs or two callers both in that VI at the same time, but it works out in practice that there's enough wires running around that the compiler generally does a pretty good job with that. So that's what, and what turns it into a functional global is when one of those actions is get or set, where you're just blatantly replacing the data that's in that shift register. And while having an init value, which you call once and set a value in, or having a shutdown that does return the value is perfectly legit, it's the ones where that's really your only access that people write these a lot, where the only two items in the enum are get and set. And that's what really is just like, no, just go use a global VI. What, you said you don't use global VIs? Well, then change your whole architecture, because that's a global VI with more overhead than a global VI.
I'm reminded of back in the day, before we had Q was an action engine that was the unit take something out of the queue.
Yep.
But it wasn't the whole queue.
But it wasn't the whole queue, right? And nothing but the queue.
And that action engine would match the paradigm of I have a directed queue.
My Aunt Cora, growing up, she out on the farm, she would tell her story at the beginning of dinner, and it was like watching a stack, every layer being pushed down, and she would jump topics, and jump topics. And then about 15 minutes before dinner, they would all start coming off the stack, and the last one would be related to the first one, and you had to have had the whole thing in your head. It has been said that it runs in the family. Anyone else?
Not number 3, the one before. Now,
One before 4?
Yeah. The number 3. Can you go back to the slide that actually has your little? Yeah, that one. I'm thinking of examples in my own code. Can you unpackage this a little more and just tell us like examples?
Well, so this is really what, the actor framework is heavily predicated on, let's take this to the full extreme of saying, I'm an actor, I'm sitting here doing things, messages come in, oh, okay, well then I'll deal with that. But I don't try to set up a synchronous request to you, because if I make a synchronous request to you, at the same time you make a synchronous request to me, I can't answer yours because I'm busy waiting on your response. And so we're now deadlocked. You can get a lot of that sort of effect even in just smaller scale stuff. But it crops up commonly in these communication systems with distributed processes. That's where it's most common, but you can have it even in the smaller scale between two while loops where you've got bidirectional communication between your producer and your consumer. I've seen people try to do pushing data down, and at the same time they're pushing data back up for trigger some sort of event or something, and they try to put some synchronization code in there, be like, I don't want to keep going until I know you've heard this, and they end up deadlocking for that same purpose. So that's really what that's about, is whenever you've got things that are happening in parallel and they're going to send information to each other, make it an announce, don't make it a request and wait for a response.
What if it's like hey, tell me this, with other stuff now?
That's fine, because because if you think about it, that's not a request, that's an announcing, I need this, and then I'm going on with my life. And the other guy going, oh, he needs that, okay, here, I'll do this. Playing word games, but word games is what the game is all about. That's what software architecture is rephrasing things to the point where it's expressible and it all functions as a system. You achieve the same effect whether you write it as a synchronous procedural program, as an object-oriented program, as a data flow, or you go write it as a functional mathematics expression in Lisp. It computationally works out the same, but the way that you express it is sometimes more scalable, more accessible. So yeah, changing the idea of how you make that request into something where I'm announcing a need and he's announcing a fulfillment for that need makes things unlatch.
It's actually, it can be very subtle, because you can almost talk about announce, request, command, command response, and you give me this and I'm going to wait for an answer as command response. And a request is still very, it still can functionally be a, I need this, but from an instructional standpoint to people, it actually is better to talk about it as an announcement even as opposed to a request. Because if you're in the mode of thinking, I'm going to go ask this other actor, and I use the term actor to mean any other process, I'm going to ask this actor for some data. I won't wait for him to answer me. I'm going to go off and do something else, but I've asked him for this. You're implying a certain amount that this object has knowledge of this other object. And that mode of thinking, even if you've done it correctly in terms of that particular request, that mode of thinking can infect other parts of your application. It really is better to think of it as an announcement. Can somebody please tell me about this? I have finished this.
Right.
And it's a change to your thinking that'll help.
All mind games. Yeah. Like the masters of programming over here, we haven't really launched any rockets in, ever.
Yeah, it was all a soundstage.
All a soundstage and some really, really good paint jobs. Yeah, I was impressed with that last one. Well, thank you for coming, and
do my announcer bit one last time. I think our next session is actually going to be the one right before NIWeek, if I recall correctly. Thanks everybody for coming out. Hope this was good. If you have not, so shoot a paper one around that was the sign-up sheet.
I have a couple of extra Snickers if someone wants one.
If you have not signed the sign-up sheet, please do. We'll, only spam you a lot. And I'll see y'all in 3 months. Yeah. Can somebody get the lights? And remote audience, thank you for attending as well. And we are signing off. Good night.